Hi guys, this is Miss Maddox here. I'm giving you a different view today. Today we're looking at the lab that we'll be doing tomorrow, which is called Balanced Chemical Equations. You should have already completed your pre-lab. Wanted to point out a couple key pieces of instrumentation. Here are your test tubes. Your test tubes are sitting in a test tube rack. When they are clean, they should be upside down. So as you see at the beginning of the lab, they are clean and upside down. When you leave the lab, they should be clean and upside down. When you're using them, you'll place them right side up on this side of the test tube rack. Also notice that each test tube has a frosted area. Some test tubes, their frosted area is blue. But on that frosted area, you can write in pencil and erase the pencil. So when it asks you to number your test tubes, that's where you're going to want to number your test tubes 1 through 6. Here are the dropper pipettes that we'll be talking about later. These are disposable. You'll need to take the piece of masking tape that you're given and label each of these 1 through 6 so that you know which one of your dropper pipettes is used for which test tube in part B. This is your test tube brush. You'll use this to, a little blurry, you'll use this to clean your test tubes in the end of the lab. Also, your lab features a part where it asks you to take dropper pipettes. Our dropper pipettes, we're a little short on them, so instead we've set up the twin burette clamp to do all of your measurements. On the left side, you have your lead nitrate, lead 2 nitrate to be precise. On your right is your, it says NaI, but this is actually potassium iodide, Ki. So on the left is your lead, on the right is your sodium. Don't mix that up. You also have a beaker at the bottom of each with that label. That will be used if you need to fill back up your burette. And then you have a waste container. The waste container is important because at the beginning of the lab, if you notice, the test tube is not exactly at 0, or the burette is not exactly at 0. You'll have to turn this dial at the bottom to get it as close to 0 or as close to a number that you know as possible. So what'll happen is at the beginning, you're at 0. And then when it says to dispense, say, 16 milliliters of sodium, of lead nitrate, you'll actually move this all the way from 0 to 16. And when it comes time to do the next measurement, you'll move it down again, however many milliliters that you need. When you need to, you will fill it back up, and your waste container remains here. Do not mix up your waste container and your fill containers. Your fill containers should have lead nitrate on them or potassium iodide. This one here, the waste container, will have a W on it. Don't mix them up. 2 different lab stations will be sharing the same burette set, so make sure to share with your neighbor. The burette set that you're supposed to use is actually positioned between the 2 lab stations, so you should be ready, set to go. At the end of the lab, when it comes time to wash your containers, you'll take a small amount of the soap that's sitting at the lab station, and that is there, right above the little piece of paper that says soap. Has a little picture of dishwasher detergent. This is the soap. You'll take a small amount of that to clean out your test tubes after you empty everything from your test tubes and your waste containers, not the burette, but your waste containers, into chemical waste. Everything that we have today is a lead compound. It'll be a lead compound. The potassium iodide can actually go down the drain, but the lead, so anything that has been combined together or anything that's just pure lead by itself will need to go in here. Otherwise, we pollute our water supply, and no one wants to die of lead poisoning. At the end of your lab, these pipettes that you had and labeled will be thrown away, and you will need to go retrieve 6 more. Ask me where, I'll tell you, but it's right between, in the drawers between, right underneath that mold box. There are drawers there that have more of the pipettes. It's between lab station 5 and lab station 6. That's where you can find those pipettes to refill. Notice that when you leave, your lab area is clean and dry. You'll need to let it air dry. You do not need to use paper towels for that. You do not need to dry the insides of your test tubes. In fact, don't dry the insides of your test tubes. If you do, you probably will get them more dirty, and in addition, you could get the paper towel stuck within them. So that's why we flip them upside down and let them dry. Since this is clean, I'm going to put it back. Anyway, when it's time to measure your different amounts of solutions, you'll physically take this off of the rack, bring it over. You may need to raise the level of your burette a little bit higher so that you can fit your test tube underneath it, and you do that by squeezing these clamps that are right there, like so. You can actually raise it up high as well, and from there, that's where you'll fill up your test tubes. Once you are done with part A, and again, part 2 and 3 of your lab has already been done for you. So if you look at it here, it says to, and you probably will be able to follow this along with this better on your own paper, but it says here that you need to number numerals with numerals 1 through 6 your test tubes. 2 and 3 are already done for you, though you may need to refill the burette. You will fill up your test tubes as it says here, but remember to make a note that instead of 0.5 molar, that's how we say that big M, 0.5 molar, which means moles per liter, and that's path D. We'll talk more about that later. This here should actually be KI, so make those changes so that you're aware. Then you'll do step 5 and 6. It says with a rubber stopper. You will not do it with a rubber stopper. Instead, you'll do it with a piece of parafilm, which is this plastic substance that'll be sitting at your desk. You'll take one little square of that and you'll flip every single time for the 3 times. Do not shake it as it says. It's very important that you don't shake. Sorry for moving in and out and giving you a little bit of the dizziness. When you get to part 7, you're actually going to measure the height of the yellow precipitate with a ruler, and then you'll go on to part B. For part B, it's helpful to have a single piece of paper. That piece of paper you can, at the top, write add PbNO3, and that should be actually PbNO3 2 on the outside because it's lead 2, but we'll talk about that later. And then on this side, it should say add Ki. You're going to put 1 drop of your supernatant. Recall that from reading your lab, your supernatant is the clear liquid above or below, but in this case above the yellow fluffy stuff that gets formed when you combine these two. This is actually the same demo that we did in class. So you'll put 1 drop from test tube 1 here and here. Then with a new dropper pipette, brand new, the one that's labeled 2, you'll put a drop here and here. And you do that so on and so on and so on and so on. There you go. Then to each of these, you're going to add a single drop of the PbNO3, the lead nitrate. You're going to add a single drop to that one, a single drop to each one. And what also is really cool is that you can then move, and you know that if there's supernatant left, it will combine. So, and you'll actually see, let me rephrase that. If your supernatant has the thing that it makes the substance with, you'll actually see the formation of your complex, because you're making lead iodide, okay? Because those are our precipitate is lead iodide. The nitrate and the potassium actually are spectator ions. So anyway, when we do the process, if the supernatant, if there's something left, you actually, the substance, the drop will actually turn yellow. And so you'll know that there is something there. It's easier to see the yellow if you slide it off of the yellow sheet. Off of the white sheet. You can actually see the yellow appearing there. We will use document protectors, so the clear document protectors that you use to protect your stuff in your binder. That's what we'll be using. For the sake of this video, I'm using something a little bit different. So you'll put the drop on each side, and then to one side you'll add the lead iodide, lead nitrate. To the other side you'll add the Ki. We'll talk about what these results mean, but on your paper, make sure that you actually write whether or not there's a precipitate. So test tube 1, precipitate, is the question mark. And in those boxes you'll write yes, there was a precipitate, or no, there wasn't a precipitate. If there's a precipitate, that means that the yellow stuff formed. And if there's not a precipitate, you'll say no, it didn't form. We'll talk about the reagent present in excess, how to find that third column there. We'll figure that out later. I also will show you how to figure out the maximum theoretical yield in the next video. So you can worry about that then. But these columns should be filled out. Actually, the milliliters will be filled out in class. Moles we'll do later. Milliliters should be filled out in class. Moles we'll do later. And then height, you're going to measure that with a ruler in class. Maximum theoretical yield, that will be done as well in class, or actually later there'll be a video on that. So video for moles and the theoretical yield of precipitate and moles. Then at the bottom, the first two rows, the one that says PbNO3 2 and NaI, that should have an answer either yes or no in that column all the way across. And then at the bottom as well, that's something that we'll cover in the next video. We'll talk about all the analysis and conclusions either in class or in the video, and all of those actually are filling in the parts that we just talked about covering later. Okay, so I'll talk to you later. Make sure that you wash your hands before you leave, and make sure that you get your safety goggles in the beginning and that you put it back at the end. Thanks so much, and see you in class next time.